In this episode, I'm going to be showing you how to set up your laptop or desktop so that it does all of the testing that you need for your large language models to prove that they're working and creating code that works properly and effectively. So let's check it out. If you've been following this series so far, by now you'll have been introduced to two powerful skills that you can use to really level up your agentic and vibe coding experience. Make sure you're delivering far more powerful code outcomes for you or your customers. So the first skill, what it did was it took a general idea, a vague idea, and turned it into a really well done professional set of requirements, the kind of thing that you would take to any project manager and allow them to do their thing with. The second skill then acted like a project manager and took those set of requirements and turned them into actual concrete engineering artifacts that any competent software developer would be able to use to design and build the feature or product that you were looking for. Very powerful skills all by themselves. What this particular episode does is shows you how to actually go about developing a testing environment that is completely repeatable and covers all of the major things that you need for good software development. It covers things like your code quality. It ensures that every single time you make a change, it's fully and properly tested. It makes sure that all of your cybersecurity elements, your generic cybersecurity elements, are taken care of. It makes sure that you use a repeatable testing environment so that there is no difference in what you deploy compared to what you tested. And it also makes sure that everything you're doing is constantly being captured and learned from. It's a very powerful skill. This is really important because in future episodes, we actually use this foundation to start building a really good testing environment that will rapidly improve and test your code. So now I'm going to run you through what it actually sets up. The first thing it does is it creates a fully containerized setup on your laptop. Now, this does mean that you need to have Docker installed, but once you do that, it ensures that all of your testing, everything that you do is always run in containers. Now, I know that it might be a controversial choice, so I'll take a little bit of time to explain why that is. One of the biggest problems I've observed over the years, particularly when it comes to understanding cybersecurity, is that people often test stuff on their laptop or on their desktop and claim that it works. And then when they deploy it into production, they suddenly find that there are packages missing. They find that there are libraries that aren't there. They find that some of the connections aren't done. And ultimately, the problem boils down to the fact that they tested their stuff in a non-replicated environment for production. That actually completely invalidates your entire testing procedure, and it's something that's entirely unnecessary in today's day and age. The way that you get around this is to use containers and Docker combined with your Docker setup files that allows you to completely replicate any environment of your choice. This is really important because your large language models have no way of differentiating between what your environment has and what your production environment has. You need to be able to replicate that locally. I would also argue that this is actually a really powerful level up when it comes to using large language models compared to trying to do it yourself. With a large language model, you can literally ask it to set up whatever you need, including all of the ways that your Docker is going to communicate with each other and making sure that that is all done. You don't have to do it. It's actually very simple for large language models to do that once you give them that direction. The first thing this skill does is set that up for you so that anytime you do a test in any of your environments, it is completely set up and set up well for you. The second thing it does is it defines all of your criteria for passing for your unit, integration, and end-to-end tests. For instance, and if you have a look at the skill that I've published to GitHub, freely available for you, you can absolutely go there and check it out. If you check it out, I define that all unit tests have to cover 90% of the code. I do that deliberately because that is a high enough bar to force pretty much any new file that you develop, any new feature to be tested and to be tested at the unit test level. I then define that all of the integration tests that have to be done and make sure that they are done. Integration tests are important because they are going to test how different parts of your code talk to each other. And finally, I define all of the user actions that need to be happening for your end-to-end testing. Again, really important, particularly if you have a user interface, because as you add new features, you want to make sure that those new features are tested without losing all the rest of them. So that's the second thing that it's going to set up for you. The third thing it does is it defines two different pre-push models. The first push is for your local development when you're just doing initial feature development, and it makes sure that you're only testing your new features and any critical parts that are required for your app. The second thing it does is it allows you to fully test any PR, and in fact it establishes that all of the testing must be done every time you push a PR. In practice, what this means is that all of your unit tests, all of your integration tests, and all of your end-to-end tests must be run before a PR can be merged into your main branch or production branch. So any PR, any feature that you develop is always fully tested before it goes into production. And that's just a really, really good way to develop software anyway. And again, I would argue is something that is just so much better than what normal people, I say normal people, but that's not actually correct. That's actually just, I think, a far more effective way of doing it than if you're trying to do it without the assistance of AI. So 2 different pre-push gates. The third thing it does is implements a whole bunch of security checks all the way through all of your code. So one of the really simple ones, any single time you go to push something to GitHub, it's going to run it through Git leaks, right? So any of those times you posted a token into your code or some other random thing, PII, that shouldn't be there, Git leaks is going to pick it up. It's very, very difficult to get past Git leaks. From there, it also does things like scanning all of your dependencies. It looks at your images, so your container images, making sure that they themselves are not insecure. And there's a whole list of different security checks that it goes through that you can absolutely check out. Now, keep in mind, all of these checks have been done in containers, so you know 100% for sure that that check has been done against your code. It literally downloads the code into the container and scans it with Git leaks and continues to do so. Because it's using Docker, because it's so fast, it just does this super rapidly and does it in parallel. So it's happening really, really fast. It keeps your code far, far, far more secure than the old manual methods that you used to have to use. It then goes ahead and starts to define deterministic ways for all of your stubs, all of your faking of different types of environments for your testing, all of your seeding and any resets that are required. So effectively it says anytime you have to do any level of testing, these are the standards that must be met. So if you're implementing something like Clerk for your authentication, it is deterministic in terms of how it's going to set that up. Therefore, it can plan around the tests that need to be done to make sure that it's fully passed. That's really important because that means that when you start to add different features to your code base, it already knows how to go ahead and set up the testing. It doesn't have to figure them out on the fly. Number one, that's going to save you tokens, which saves you time and saves you money. And number two, it's going to ensure that the testing results that you get are very, very deterministic and radically improve your actual coding outcomes. From there, it includes some really, really practical tools, such as it bounds its runners. It makes sure that there's heartbeats for all of your testing, so you don't just freeze on something for 12 hours while you're asleep and burn tokens on it. It makes sure that there's logs and there's artifacts to process, so it sets in place all of those just standard things that help your thing run better, run more efficiently. Then it sets up your flake and quarantine policies. So for instance, if you've got a flaky test that sometimes passes and sometimes doesn't, it'll investigate to find out where the race condition is and fix it. And it sets in place your quarantine policies for if something is really going wrong and it needs to stop. Finally, it sets a repo-local agents.md, or if you're using Claude, claude.md. This is actually really important because this allows your agent to leverage the statistical power of large language models to make decisions on the fly and effectively replicate some thinking. For instance, if you just have a really simple flaky test that just needs to be fixed, you don't need to do any hardcore analysis of it, you can set that up in your agents.md. This particular agents.md is repo-local, so you can have it on this repo and not on a different repo. You can customize it, and we'll get into more of that when we start talking about the self-learning thing. Now, you might be looking at this and being like, that's amazing, I wish I had had that for an existing repo. Well, I'm pleased to tell you that the way that I've set up this skill, you can actually apply it to any repo, whether it's a new one or an old one, and it'll actually figure it out for you. Now, that's really cool because that means that no matter where you're at in the software development journey, you can absolutely implement this straight away. And combined with the other skills that I'm showing you on this channel, you'll 100% be able to improve your software development no matter where you start from. What I thought I'd do is quickly run you through the process of how it goes about doing its work. That'll just give you an idea of what to expect and maybe some timelines around how long it actually takes to do. The first thing it does when you implement the skill is it'll gather some factual requirements around the repository that it's going into. If it's brand new, it knows that. If there's existing code bases, it'll know that. If you're using some language that it doesn't know about, it'll go to the internet and find out what it needs to replicate in order to achieve the level of security that it's designed to do. Then it builds a map of any testing gaps that exist. It drafts a repo testing design and it will present that design to you. So it effectively does an analysis of the environment that it goes into, figures out what it's going to need, and then comes to you and says, hey, here's all of the things that you need. Do you approve? If you don't approve, that's fine. You just keep chatting with it until you reach a shared understanding, and then it will go ahead and build it for you. Once it's set it up, it'll check that it works. It'll make sure there's no way to get past your PR gates without getting fully tested, and then it'll commit that work to your repository. Now, if I zoom back out into where we're going with this particular series and where we're going with these skills, hopefully you're starting to see the pattern here. Number one, take vague requirements, turn them into something that's powerful. Number two, take those set of requirements, turn them into an engineering artifact. Number three, prepare your testing environment, and I'm sure you can already guess what the next one's going to be. Well, that's the end of this episode. Don't forget you can get all of this on my GitHub repository for free. Absolutely no concerns there, and all of the information that I cover is covered over there. If you like what you're seeing, don't forget to like, subscribe, and set up the notifications so that you learn when I'm getting more content out there. And don't forget to drop me a comment in there if there's something you'd like me to teach you or show you or share with you that I haven't done so already. Otherwise, I'll see you on the next episode.